Hackers infiltrated a polished railway network by sending unauthorized radio stop commands by inexpensive equipment, causing 20 trains to stop at emergency state. Millions of drivers and operators communicate on daily basis to make things work smoothly in this transportation sector. From trolleys to buses, from trains to airport services, everyone needs a secured and safe and clear transportation communication protocols. Even a 5-minute stop would not sound much, but in a critical network, lots of cost, delays, and thousands of passengers are impacted.
AI-enabled attacks like voice spoofing can bypass traditional verification measures. We've all seen the meteoric rise in voice cloning technology. All it takes is 5 minutes of audio in order to create a convincing replica of a family member, a friend, or in this case, a coworker. It is simply too easy to manipulate someone over digital communications. Current security standards are not enough.
In San Diego, transit systems use radio frequencies so dispatchers can communicate to operators and vice versa. However, radio transmission channels could be intercepted by malicious actors and replaced with deepfake audio to impersonate transit dispatchers. Our system verifies commands at both ends. We will use biometric authentication to initiate a transmission on both sides, and we will check the authenticity of the voice using a deepfake signal analyzer only before the transmission goes through. The deepfake signal analyzer is on both sides of the channel.
In order to approach this solution, we will use a deepfake signal analyzer to check if a voice is authentic or a deepfake. In order for the deepfake signal analyzer to work, we will first create our own custom AI model. To start, we will collect or use a dataset of deepfake and real audio samples, which can vary in size, such as 10K audio samples. Once we have this dataset, we will then have to clean it up and pre-process it so that the model can be properly trained on it. This pre-processing can include formatting the raw audio into the understandable format, extracting relative features for the model, such as pitch and data augmentation, to make our model robust against adverse conditions. This way, our model can be fit to detect deepfakes at MTS stations.
We will optimize the AI model so that it will maximize precision. Prioritizing more false positives over false negatives is crucial because the MTS can ensure that potential threats are flagged and investigated, minimizing the risk of overlooking actual malicious activities. A convolutional neural network will be used to detect anomalies from the feature extraction of large datasets, specifically variation in speech pitch. Similarly, an LSTM will be used to recognize unnatural speech patterns, both red flags hinting at deep faked audio. The custom model will then be exported to edge devices, hardware which is capable of running inference using our deepfake detection model. Using these AI accelerators, we can detect if the audio is malicious or not immediately.
In order to implement our solution for the current MTS trolley system, there are a few hardware components that are needed. The first would be standard fingerprint scanners at both the dispatcher and operator ends. For the proposed AI deepfake detection model, we're suggesting the use of Pi 5 Halo 8L or Jetson and Nano microcomputers, as they're easily accessible while providing real-time capabilities. Our solution in total will cost around $45,000. Alternatives to our solution, like encrypting communication channels, will cost around $115,000, making ours much more cost-effective.
One of the best aspects of our solution is how scalable it is because of its lower cost. This can expand our implementation into other sectors where communication security is just as important, such as healthcare, commercial services, and emergency services. Our AI system also utilizes AI without training on employee voices or breaching privacy concerns. We propose the most effective and feasible solution that ensures that our real verified commands reach drivers, keeping transportation safe from AI-based cyber attacks.